Alright, so today our lesson is section 3.2, day 1, and essential question, when parallel lines are cut by transversal, what do you know about alternate interior angles? So you answer that in your EQ, about alternate exterior angles, so that's the same kind of thing, but what do we know about those? About corresponding angles, and then what do we know about consecutive interior angles? So today we're going to learn that. So one main idea today is reasons for proofs. So these are more things that we can use in the reasons column for our proofs. All right, so the first thing is called corresponding angles postulate. And what that says, and I'm going to write it a little weird because this is what I'm about to write is really what you're going to write for your reasons. You're not going to write the name of it. What you're going to write is if parallel lines, so if in the given information, so if is like your given information, if they tell you have parallel lines, then you can conclude that corresponding angles are congruent. So if they tell you in the given, so the if is the given part, if in the given they say you have parallel lines, then you can conclude that those corresponding angles are congruent. And remember the other day we learned that corresponding angles are angles that are in the same position, like the top left in that group of 4 and the top left in the next group of 4. Okay? So if we know we have parallel lines, then we can say that the corresponding angles are congruent. So that's going to help us solve some things. The next one is the alternate interior angles theorem, and you guys can pause whenever you need to if I'm going too fast. So alternate interior angles theorem says if you've got parallel lines, so again that has to be in the given, then alternate interior angles are congruent. Okay, so this would be an example where if you've got parallel lines, remember how we mark parallel is the arrow, then let's say I had angle 1 and angle 2 here, those are corresponding angles, so I could say angle 1 is congruent to angle 2, so that's going to help us find angle measures. This one's saying that if you've got parallel lines cut by this transversal, then alternate interiors would be like this one and this one, so I'll call them 1 and 3 because they're diagonal and in between the two parallel lines. So then I can conclude that angle 1 is congruent to angle 3. So again, that's going to help us find angle measures when you know that the lines are parallel. The next one is the alternate exterior angles theorem. So again, this starts out saying if you've got parallel lines, then we can conclude that alternate exterior angles are congruent. So what that looks like is if you've got parallel lines and they're cut by transversal here, if I had this angle here, 2 and 4 over here, these are alternate exterior angles. And if these lines are parallel, then I can conclude that angle 2 and angle 4 are congruent to each other. That's what this theorem says. And again, you can only do that if these lines are parallel. These three things don't work like the problem we had on Friday where it was these lines weren't parallel, so then we could only name the different types of angles, like which ones were alternate exterior angles, etc. But we couldn't say anything about their measures. Now, if we know the lines are parallel, then we can say that alternate exterior angles will be the same measure or be congruent. The last one, that fourth type of angle, was either same side interior angles theorem or consecutive interior angles theorem is what your book is going to use. That's the CIA. This is the oddball. This one says if you've got parallel lines, then SSIA or consecutive interior angles are supplementary. Okay, so this one is the oddball. The other three corresponding angles, alternate interior angles, and alternate exterior angles, those angles are congruent to each other when you have parallel lines. The same side interior angles or the consecutive interior angles, they are supplementary if you have parallel lines. So that's if got my parallel lines cut by this transversal. So angles 1 and 2 here, There's 2, 1 and 2. Those are consecutive interior angles because they're in between the two lines and on the same side of the transversal. So then I could say measure of angle 1 plus measure of angle 2 equals 180, because remember that's what supplementary meant. So that's the same side interior angles theorem or consecutive interior angles theorem. Okay, so now let's see how those are going to help us with our problem. So this is an easy enough picture. Go ahead and sketch that, so you can pause while you guys sketch that into your left-hand column. Okay, so part A, it says find the measure of all the numbered angles using the given info. So it's given that line A is parallel to line B. So I told you that's what all those ifs were in our if-then statements for these theorems and the one postulate. If they tell us in the given we've got parallel lines, then we can use those things to find different angle measures. So notice they give us angle 1, so we need to find 2, 3, 4, 5, 6, 7, 8. So I'm going to put 125 degrees here. Now, which angle corresponds to angle 1? Angle 3 does. So that means since these lines are parallel, and I forgot we need to mark that in our picture. We learned that on section 3.1, how to mark parallel in your picture. Since these are parallel, then I know 1 and 3, these corresponding angles are going to be congruent to each other. So I know that's 125 degrees. What kind of angles are angles 1 and 5? Angles 1 and 5 are alternate exterior angles, so the AEA theorem says that if these lines are parallel, then these alternate exterior angles have to be congruent. So I know that's 125. You could have also gotten this to be 125 because 3 and 5 are vertical angles, and we can still use what we know about vertical angles. Okay? And then angle 3 and angle 7 are alternate interior angles, so if these lines are parallel, then we know alternate interior angles are congruent. So that's also 125. Okay, so I know measure of angle 3 equals the measure of angle 5 equals the measure of angle 7, and those all are 125 degrees. This is an alternative way of writing it. Instead of writing measure of angle 3 equals 125, measure of angle 5 equals 125, all separate. Since they all have the same measure, you can string it along in one like this, so it will be a little less writing. Okay. All right, well now we have to find 2, 4, 6, and 8. Well, 2 and 3 are consecutive interior angles, so to find the measure of angle 2, we know that these lines are parallel, so consecutive interior angles are going to be supplementary. So to get the measure of angle 2, I'm going to take 180 minus the 125, which is going to be 55 degrees. So measure of angle 2 is 55 degrees. Well, 2 and 8 are vertical angles, so then I know angle 8 is also 55 degrees. And then I'll also know that 8 and 4 are alternate exterior angles. So since 8 and 4 are alternate exterior angles and these lines are parallel, I know angle 4 is also 55 degrees. And I could do vertical angles with 4 and 6, and we know vertical angles are congruent, so then angle 6 is 55 degrees. So then we know the measure of angle 2 equals the measure of angle 4 equals the measure of angle 6 equals the measure of angle 8, and they are all 55 degrees. Okay. Now notice, when you've got parallel lines cut by a transversal, I only need to be given one angle, and from that one angle, I could have used that corresponding angles postulate in those 3 theorems to find all of the other ones. Also, we use vertical angles. So we can use all of that stuff we know, and I could have found all other 7 angles just given one angle when you've got parallel lines cut by a transversal. Okay? All right, so now let's look at B. On this one, erase here. I'm going to erase all this because it doesn't carry on, except for the parallel because that was in the given. Alright, so I'll do this one in blue. Okay, so this one we know the measure of angle 7 is x degrees. So then see if you can figure out which other angles are also going to be x degrees. So pause it now and then figure out, write on your paper what you think other angles are that'll be congruent to angle x and write that out. Alright, so we should have had measure of angle 1 because these are vertical angles, so that'll be x degrees. Measure of angle 3 because those are alternate interior angles, and since these are parallel, they're congruent. And then you could have done 7 and 5 because these are corresponding angles, and if the lines are parallel, corresponding angles are congruent. So I know measure of angle 1 equals measure of angle 3, because they already gave us 7, equals measure of angle 5, which is x degrees. Okay? All right, now we need to find 2, 8, 4, and 6 again. Well, how did we go about finding, when we were given 3, we found out 3 was 125 degrees. How did we figure out what angle 2 was here? Well, we did 180 minus that given angle, and we're going to do the same thing here. We're going to do 180 minus the x, and then that's as far as we can go. And then that means angle 2, angle 8, angle 6, and angle 4, those are all going to be the 180 minus x. And we did something like this on your chapter 1 test when we were doing supplements, and I told you one of it was x degrees, and so you had to do 180 minus x. That's as far as you can go. So those other angles are going to be 180 minus that given angle. Okay? All right. Now this example is provided for you, so I'll have the sub pass this out and you glue this into your left-hand side. This will conclude this video. So if you get this far, great. Play the next video and see how much further you can get. If not, we'll pick it up where needed tomorrow. So glue this example in and then we'll start the next video.